Good day, students, scholars, and curious viewers. This is Mr. SKT, otherwise known as Super Karachi Teacher. In this video, we're going to be doing the measurements section of mathematics literacy. More specifically, the actual measuring part, and not conversions. That's usually early on in your syllabus. This is what is normally done in term 2. In this lesson, we're going to be going over the 4 key concepts that involve measuring and measurements and how to actually measure them. What are those concepts, you may ask? They are length and distance, mass or weight, volume and capacity, and temperature. This lesson is going to have quite a lot of notes, so pause the video if you need to in order to catch up. With that being said, let's continue. What is needed in order to measure each of the above, being each of the different concepts that we are going to be measuring today? 2 things you essentially need to have on you. Number 1 is, and most importantly, you need the right tools for the job. One needs the right tools that are specific to that concept, and if you don't have the necessary tools, then you can use your skill of estimation to give yourself a rough idea of the measurement. So aside from having each tool for each necessary concept, for length, you need something that can actually measure length. For temperature, you actually need something that can measure temperature. But if you don't have those things on you, then what you can do is give yourself some form of idea that you can use to compare when you actually get the tools needed for an accurate job. Now let's go into the specifics, starting with measuring length and distance. Now, I've been using length and distance as though they were 2 separate terms. So what is the actual difference between length and distance? Well, in terms of like everyday usage, length is how long something is, and distance refers to the space between 2 points or places. I understand this is not the proper scientific definition of distance, but in terms of everyday life, which is what mathematics literacy is all about, it gets to the point. What is the unit of length for length? So the metric unit of length, you get 2 types of units. You get the metric unit and imperial units. Metric units are like the most scientifically accepted unit, and the standard in which most of the world tends to, when I say most of the world, I'm not actually sure what percentage, but a large percentage of the world uses. Imperial units are an alternate one that have had a lot of relevance in history and are just as relevant as the metric unit. So the metric unit for length is the meter, represented by a small letter m. And this includes its other versions or variations, which the 3 examples I've enlisted here are millimeter, centimeter, and kilometer. I've used these 3 in particular because these 3 are the most used in terms of like everyday usage. As I said, there are other units for length and distance. These are known as imperial units. And some of these include miles, yards, furlongs, inches, etc. So you tend to see them more with American media. But like I said, they are just as relevant as the metric unit. Are we expected to memorize all the conversions between the units? Between metric units? Yes. You are expected to memorize like how many centimeters in the meter in order to convert, how many kilometers how many meters make up a kilometer, and how to convert millimeters to centimeters, kilometers, etc. You are expected to memorize that. In maths literacy, though, when any conversion that involves imperial units, so from metric to imperial, from imperial to metric, or imperial to imperial, the educator examiner usually provides you the rate of conversion. So if the examiner is asking you, for example, to convert 5 inches into centimeters, they are required to tell you that 1 inch is 2,54 centimeters. And then you use mathematical manipulation in order to convert. What tools or equipment are used to measure length and distance? So there's a few that come to mind. There's a few that come to mind when it comes to basic usage, and that is the first one and the most reliable, the ruler. Here's a little example of your standard ruler. So your standard ruler, which is used by students, measures in at about 30 centimeters, and you do get variations. You do, for example, the t-square. Hopefully I get a decent picture here. That could be better, but the t-square, which usually measures at 100 centimeters, that's typically used by engineering students and architects, as well as the smaller 15 centimeter ruler, which fits in your standard math set. The next one, measuring tape. Think ruler, but it can measure in meters at a time, and it also contracts so it can fit in your pockets. So like this is a measuring tape. It pulls out to about in this one's a 5 meter measuring tape. And with a push of a button, you can lock it in place. You can lock it in place and then just push a button in order for it to go back into sort of that pocket, so it can go back into your pocket. Then you also have this type of measuring tape. Let me just get the light out the way. Yeah, this type of measuring tape is more like flexible, and how do I say, like, it's meant to go around an actual object, but and doesn't exactly have the mechanisms of a normal measuring tape. Next we have what is known as a trundle wheel. This is a trundle wheel, or a metric measuring wheel. So the way this one works is it's a wheel with a handle attached to it. What happens is it's usually used by engineers, architects, etc. People who like measure like, how do I say, like larger distances of land, especially like not smooth land. But because the way this works is that a trundle wheel or a metric measuring wheel, you hold the handle and you roll the wheel along the ground, and as the wheel is turning, there's sort of like a counter. There's a counter attached to it that sort of measures the distance the wheel has rolled. So as I put here, used to measure distance by rolling on the ground between 2 points. It's useful because it measures the distance whilst going up and down hills. That's the usage of the wheel. And finally, you have odometers. So the odometer is usually it's that number that you typically see below the speedometer of the car, or it's usually somewhere in your car. Usually a 6-digit number or a 5-digit number in this case. And what the odometer does, it tells you how far the car has traveled usually in its lifetime. So in this case, this particular car at the time in which this picture was taken had done 91,308 miles. And the way the odometer actually measures how far the car has traveled is usually similar to the trundle wheel. It measures how far the wheels have actually turned. How far the wheels have turned and as a result, like the different shafts in the car. A mechanic will probably be able to, a mechanic or someone who actually knows a bit more about cars could tell you a bit more. But anyway, that's measuring units and the tools associated with length and distance. Let's move on to the next one. Measuring mass or weight. So the first one, firstly, is there a difference between mass and weight? In general terms, in general society's use of the terms, no. In terms of scientific definition, yes. As a former physics student, I can acclaim to this. When we use the terms mass and weight, in terms of physics, they are two very different things. However, in everyday usage and everyday use by society, mass and weight tend to mean the same thing. So, maths literacy students, you do have the permission in this case to throw around these two, to use these two, to sort of interchange these two. Just make sure you don't do that around physics students. What is the unit of mass? So there are metric and imperial units for mass, just like how there's metric and imperial units for length. And in case of mass, the metric unit for mass is the gram. This includes its variations, such as there's only two really relevant ones, being the milligram and the kilogram. I understand that the metric ton is also another variation, which also gets used just as much as the kilogram as well. I didn't really include it here because it didn't have the word gram in it. And the imperial units for mass include things like the ounces and pounds. There's also another sort of ton. I think it's called a short ton, where it's the imperial unit, where it's an imperial unit, but it also has the word ton in it. I think that one is more like 900 kilograms as opposed to the 1,000 for a metric ton. What tools or equipment are used to measure mass or weight? The scale is the main tool for measuring mass. Therefore, we have scales of different sizes that are meant to measure the masses of different categories of items. The two most well-known scales are the kitchen scale and the bathroom scale. The kitchen scale is used to measure masses of food items for accurate amounts for a recipe. So, in terms of the kitchen scale, you usually get two variations. You get your normal what I call manual kitchen scale, where you literally load it on in a sort of bucket sort of thing, and that activates the spring that lowers the spring, which gives you a reading of the mass of what's in it. And then you get the digital kitchen scale, which does the same thing, but it shows you the mass in a digital format. Then you get the bathroom scale. The bathroom scale is large enough to measure the mass of an average person. So bathroom scales, of course, are much bigger than kitchen scales, and that's so they allow a actual person to stand on that and take their mass. That's it, and that's mass and weight. Let us move on. Measuring volume and capacity. The original notes in which are expected of you is only volume, but I've added the capacity in here because of one very important question that I want to point out to you students. Are volume and capacity the same thing? The short answer, no. This confusion is a result of general interchanging of the two terms. People tend to say volume when they mean capacity, and they tend to say capacity when they mean volume. And people tend to think that volume and capacity are the same exact thing. But if you do a little research, you find out that no, they're not the same thing. See, volume and capacity are two different terms with different usages and their own units. Volume is the amount of space a three-dimensional object takes up. And capacity is the measure of the amount of solid, liquid, or gas that an object can hold. So let's say I take this box, for instance. The amount of three-dimensional space this box takes up is what I call the volume. But if I wanted to know how much water this box could hold, then I would need capacity. So that's a little bit of a example of the difference between volume and capacity. What are the units for volume and capacity? Now this is where it also gets a little bit weird. You see, you get units for volume, you get units for capacity, but there are actually three categories of units for volume capacity. Some of you may be confused about what's this third one. Well, here's the three. This is the way that I have split them up. So the first one you get is general volume. The metric unit for general volume is known as the cubic meter, represented by a m to the power 3. The variations of this one include the cubic millimeter and the cubic centimeter. Yes, you do get things like cubic kilometers and etc. Though these are the three that are most used. General capacity, the metric unit for this one is the liter, represented by a cursive L. And its variations include the milliliter and the kiloliter. You do get things like centiliters and all that, but more specialized industries deal with centiliters and all that. The imperial units include gallons, quarts, and pints. Those are just a few to speak of. There are like fluid ounces, etc. Those are the first three that came to mind. And then the last category is what I call food specific. These ones are commonly used in terms for ingredients and recipes, and they include cups, tablespoons, teaspoons, etc. So things you would typically use to measure out food. And then what tools, equipment are used to measure volume and capacity. So in terms of everyday usage, there is not really any specific apparatus needed for measuring volume. There's a lot of scientific methods for measuring volume. Science students would tell you of Archimedes and how we use water displacement to get the volume of a crown, but we do have some tools for everyday usage. You have your measuring cups, tablespoons, teaspoons, and also any container that you know its capacity. Like if you have a 5-liter ice cream tub, you know that tub can hold 5 liters. So that's also something you can practically use in everyday life. All these things are all practical for measuring volume and capacity. And that's the third one. And that's the third concept, which leaves us with the last one, being the measuring of temperature. What are the units for temperature? There are 2 units. 2 units for everyday life of temperature. There's degrees Celsius, represented by the degree sign and a large C. And then there's degrees Fahrenheit, which is represented by the degree sign and a capital F. Degrees Fahrenheit is usually used by the United States, as well as another number of island nations from the Caribbean, as well as the Western Pacific. Degrees Celsius is used by the rest of the world. In other words, every other country aside from the ones that use Fahrenheit, which is a very, very large number. What tools or equipment are often used to measure temperature? Just like how the scale is the universal main tool for mass, the thermometer is the main tool for measuring temperature. I mean, it's in its name. Thermo means heat, and meter means to measure. So thermometers measure heat, measure temperature. And like I said, much like the scale with mass, there are different versions of thermometers that were made with the purpose of finding the temperatures of different things. Let's see if I got my pictures ready. Okay, the first one is the outdoor thermometer. This is kind of what it looks like. Usually you strap this one on the wall of the outside, and the whole thing with this thermometer is it measures the temperature of the air outside. So it gives you the temperature of the air as it is. The next one is the digital thermometer. These have become very popular of recent because, well, you know why. So these ones work. These are the digital infrared thermometers. These work by essentially pointing them at your forehead or whatever body parts, and they take the temperature of that area in which they are pointing to. The next one is the internal or body thermometer. They look kind of like this, otherwise known as the I'm gonna butcher the pronunciation. Bureau thermometer. So the way this one works is that it takes a person's internal temperature by essentially inserting that thing in the person's mouth, usually under the tongue, putting it underneath the person's armpits or inside their rectum, which is actually the number one place you should be putting there for the most accurate reading. And it takes their internal body temperature. And then finally, the meat thermometer. Yes, it's a thermometer that is connected to a spike. It will be very painful doing a rectum thermometer check with this one. But anyway, this one's associated with the culinary arts. What you do with this thermometer is it's inserted into a piece of meat and it reads the internal temperature of the meat as it cooks. Why this is important, especially with like meats that have different temperature ranges, like rare, medium rare, etc. Because it's usually it's about like a 10-degree Fahrenheit change from rare to medium rare, if I'm not mistaken. Correct me if I'm wrong, please. So it's important for a culinary student or a chef to be able to accurately check the temperature of the meat as it is cooking so they know not to overdo it. Because some meats tend to go very chewy or very rubbery if overcooked, and chefs usually demand perfection with every dish. And that, my students, is the complete lesson, well, our complete first lesson, at least, for the whole measuring of length, distance, mass, volume, weight, volume, capacity, and temperature. This lesson is usually meant to be done in term 2, where after you already associate yourself with conversions. If you enjoy this video, please leave a like, share, and subscribe. It goes a long way, and also comment on what you would like to see in the future. With that being said, have a nice day.